Millions of people have reported near-death experiences. They describe tunnels of light, feelings of peace, and sometimes encounters with deceased loved ones. But here's the wild part: science is starting to unlock what's actually happening in your brain during these moments. And the answers might fundamentally change how we understand consciousness itself. Stick around as we count down the 10 most shocking discoveries about near-death experiences and what they reveal about the human mind. Most near-death experiences happen when the brain is actually dying. Research from the University of Michigan found that brain activity doesn't flatline immediately when the heart stops, it actually surges. In a landmark 2013 study, neuroscientist Jim Borjagian measured electrical activity in rats after cardiac arrest and discovered a burst of coordinated brain waves in the final moments before death. This same pattern has been observed in humans. The surge includes gamma waves, the frequency associated with conscious awareness and memory. What's fascinating is that this hyperactivity might explain why NDEs feel so vivid and real. Your brain is literally firing on all cylinders, creating an intensely conscious experience even as you're technically dying. About 10 to 20% of cardiac arrest survivors report having had a near-death experience. That's surprisingly consistent across cultures, religions, and countries. A landmark Dutch study published in The Lancet followed 344 cardiac arrest patients and found that exactly 18% reported NDEs. What's crucial here is that these experiences don't correlate with medication, oxygen levels, or brain damage, factors you'd expect to vary based on medical circumstances. Instead, they seem to occur at random, regardless of age, education, or religious background. This randomness is actually one of the most scientifically interesting aspects, because it suggests NDEs aren't hallucinations triggered by a specific medical event, but rather a genuine neurological phenomenon that only happens in some people. The tunnel of light, maybe the most iconic feature of NDEs, might be explained by your brain's visual processing breaking down. When oxygen to your eyes and visual cortex drops, the cells in your retina actually start to die from the center outward. This creates a literal tunnel effect, where your peripheral vision goes dark first while the center remains bright. Neuroscientist Jean-Paul Fischer has proposed this model based on what we know about oxygen deprivation and retinal function. But it gets deeper. As your brain tries to make sense of this fragmentary visual input, it might fill in the gaps with bright light. The tunnel effect has been experimentally produced in laboratories by stimulating the visual cortex in specific ways, and pilots experiencing G-force-induced unconsciousness often report similar tunnel vision phenomena. Many NDE survivors report seeing deceased relatives and feeling an overwhelming sense of peace and unconditional love. Neuroscientists believe this is connected to the brain's temporal lobe and dopamine systems. The temporal lobe is involved in memory, emotion, and our sense of self. When it's disrupted during oxygen deprivation, it can trigger the recall of deeply encoded memories, especially of people we loved. Meanwhile, the brain's reward system, flooded with dopamine and endorphins as a response to extreme stress, creates that signature bliss and peace. A Canadian neuroscientist named Michael Persinger even showed he could induce similar experiences in lab subjects by stimulating the temporal lobe with magnetic fields. This doesn't mean the experiences are fake, but rather that they're generated by real, measurable brain activity. Some NDE survivors report accurate perceptions of what happened around them while they were clinically dead, a phenomenon called veridical perception. The most famous case involves a woman named Pam Reynolds, who had an out-of-body experience during brain surgery where she reported seeing the surgical instruments and hearing the surgeons' conversations. When investigators later verified her claims, the details were accurate, even though her brain activity was flatlined. However, these cases are rare and difficult to study scientifically. Skeptics argue that people could pick up fragments of information before losing consciousness or after regaining it. Most neuroscientists remain cautious, noting that while these experiences are profound and genuine, we don't yet have a mechanistic explanation for accurate perceptions during unconsciousness. The feeling of moving through a tunnel or up toward a light might be connected to how your brain processes motion when it's starved of oxygen. Neuroimaging studies show that when the brain is hypoxic, low on oxygen, it can create intense sensations of movement and weightlessness. This is partly because the vestibular system, located in your inner ear and integrated with your brain's sense of balance and spatial orientation, becomes hyperactive. Combined with the visual tunnel effect we discussed earlier, your brain literally constructs the sensation of accelerating forward into light. Astronauts and fighter pilots who've experienced extreme G-forces report remarkably similar sensations of rushing upward or forward. In other words, your brain might not be traveling anywhere, but it feels absolutely real because your brain is generating the sensation of motion from the bottom up. Interestingly, NDEs often seem to improve people's mental and physical health long term. A study by cardiologist Pim van Lommel followed NDE survivors for years and found they reported less depression, less fear of death, and greater life satisfaction compared to cardiac arrest survivors who didn't have NDEs. They also reported greater life purpose and spiritual orientation. This is neurologically significant because it suggests that whatever is happening in the brain during an NDE creates lasting changes in neural circuitry related to emotion regulation and motivation. The experience literally rewires people's priorities. This isn't just psychological comfort. Brain imaging studies show actual changes in how NDE survivors' brains process emotional information. Whether the experience is purely neurological or something more remains debated, but the measurable health benefits are very real. The brain's default mode network, a system of interconnected regions that activates when you're not focused on external tasks, appears to remain active during NDEs. This network includes areas involved in self-reflection, social processing, and autobiographical memory. When most of your brain is shutting down from oxygen deprivation, this network actually seems to fire more intensely. Neuroscientists have proposed that heightened default mode activity during dying might explain why NDEs often involve intensely personal experiences, vivid memories, and a sense of self-observing the scene. Brain imaging shows that people with high spiritual experiences tend to have more connectivity in default mode regions. This suggests that NDEs aren't random neural noise, but organized patterns of activity centered on consciousness and identity, the deepest aspects of what makes you, you. People who've experienced NDEs often describe an expansion of consciousness beyond their individual identity, a sense of merging with something universal or infinite. Neuroscientific research on meditation and psychedelic experiences suggests this might involve a temporary breakdown of neural networks that normally maintain the sense of individual selfhood. The posterior cingulate cortex and medial prefrontal cortex, regions that create your sense of separate identity, show decreased activity. Simultaneously, regions associated with present moment awareness and emotional processing become hyperactive. Strikingly, this neural pattern mirrors what happens in deep meditation and certain psychedelic states. Brain imaging of experienced meditators shows similar connectivity changes. This doesn't explain away the profound nature of these experiences, but it shows that radical shifts in consciousness correlate with measurable changes in how your brain integrates information about self and world. Here's the most mind-bending discovery: the brain might have different levels of consciousness that exist independently of simple on-off states. For decades, neuroscientists assumed consciousness required a functioning cortex and that brain death meant the end of consciousness. But research into NDEs, comas, and anesthesia suggests consciousness might be more like a spectrum than a switch. Some people regain consciousness from deep comas and report vivid experiences from periods when brain scans showed minimal activity. Recent studies using advanced neuroimaging found that some patients in vegetative states had detectable brain activity related to consciousness that wasn't visible on standard scans. This challenges our fundamental definition of consciousness itself. If the dying brain can generate vivid, organized, sometimes meaningful experiences through patterns we're only beginning to understand, it raises profound questions. What exactly is consciousness? Is it tied exclusively to the physical brain, or could there be aspects of awareness that persist beyond our current ability to measure? These questions keep neuroscientists and philosophers up at night. Near-death experiences reveal that consciousness is far stranger and more complex than we once believed. If you found this exploration of the mind as fascinating as we do, please hit that like button and subscribe for more deep dives into neuroscience, psychology, and the mysteries of human consciousness. Drop a comment telling us, have you or anyone you know experienced an NDE? We read every comment, and we'd love to hear your story.